Hey, good morning, everybody. Welcome to another live stream with Montana Outdoor Science School. My name is Melanie, and today's subject is the rock cycle. I'm going to talk a little bit before I get started, gives folks some time to hop online and join us here. MOSS is an organization where we try to get kids excited, interested in science, nature, the outdoors, being outdoors, experiencing it, whatever it takes to get them outdoors for the school year or for the summer. We have school programs where either MOSS goes to classrooms or classrooms come to us. We also have summer camps that take place. This year it's going to be a little different than what is normal just because of COVID-19. And these live streams too are kind of a product because of COVID-19. We want to get people able to be a part of our program still, to be able to watch what's going on. We want to give something to the community still. So we're doing live streams twice a week at this point, every week at 11 a.m. and at 11 a.m. on Wednesdays and on Fridays as well. And today, like I said, is all about the rock cycle. Before I get started though, we have to go over some of the basics of rock stuff. So let me get started with the basics of rocks. All rocks are made out of minerals. Minerals are various chemicals, various compounds, molecules that are together. In the case of rocks, they can be made out of 2 or more minerals. Let me show you. I have a little pile here. My little pile of rocks. These are all minerals, meaning they all contain just one type of chemical compound. With these ones here, I'm sure these look a little bit familiar to you. If you've ever been out to rivers, you might see little flakes floating in the water. Sometimes it's fool's gold, but sometimes it's little flakes of mica, and that's what these are here. So that's a type of mineral there. We've also got, let's see, this one, this pretty white one. It's actually quite shiny in the sun. I wonder if I can get that to show for you guys how shiny it is. Medium. Oh yeah, there we go. Shiny. That one is a type of quartz, so that one's also a mineral. So basically, rocks are all made out of at least 2 or more minerals. These ones here are just made out of 1 minerals, like I said. But moving along, we have 3 different types of rocks that are in the world, and I'm going to show you guys the setup I've got here now to kind of demonstrate it for you. We've got 3 major types of rocks. We've got the igneous section, we've got metamorphic, and we've got sedimentary. All of these have different types of minerals in them depending on what kinds of processes rocks go through. They may become one of these types of rocks here. With the igneous rocks, igneous is a word that is it takes its root word from a Latin word meaning ignis, or that is ignis meaning fire. So these types of rocks come from magma or lava. If you've ever done any kind of studying of rocks, magma is what is underneath the crust of the earth. That's the hot molten rocks within. Versus lava is hot molten rock that is now on the surface of the crust. So this is where we get the typical ideal lava coming out of a volcano sort of situation. The specific rock I have here is some type of, what is it now? It's called scoria, I want to say, which is similar to pumice. It's very, very light. If I tap it on the cement, listen to this. It's super, super light. It doesn't make hardly any noise at all, versus this metamorphic one. Super heavy, super dense. The igneous rock here, this scoria, was something that flew out of a volcano. It was filled with tons of gases, which is why it's got all these little pits and little holes in it. The gas was escaping out of here, and that's what caused all these little divots in here. And that's also what makes it so light. It was mostly air when it came out of the lava here. Because I am outdoors today, please let me know if you are having trouble hearing me at all. I'm happy to take this indoors. I've got the ability to do that, but also I just want to know that if you guys have any questions at all, please feel free to type that into the comment section, or if you yourself are a geologist, please feel free to add to the conversation. I am not necessarily a geologist myself, but I do know enough of the basics of rock and the rock cycle to be able to talk about it, so I'd love to hear from any geologists out there. So that was their igneous rock there. Lava, magma sort of rocks. However, it's not the only form that igneous rocks can come in. Let me show y'all what I've got. So I've got lots of little examples of all sorts of igneous rocks, and look how different they all look. This is why geologists are so cool and why the thing they study is so neat, because they would be able to tell the difference between every single one of these. I only know the difference because I had to look it up, and they all have convenient little numbers, and we have a nice little chart talking about them all. This one here, super light too. This one's true pumice. It's kind of white and it's super airy. Then we've got, ooh, this one's basalt. If you've ever been up to Palisade Falls has huge basalt columns up there, and they're really, really something. I wish I could talk in huge detail about them. Basically, the formation of those columns up at Palisade Falls is the result of magma having cooled down. As things go from a liquid to a solid, they often have a crystal structure that they will kind of rearrange themselves into. We see this with ice. If you've ever seen a snowflake, every snowflake starts with at least 6 arms, and then they just kind of grow bigger and bigger from there. That's the crystal structure of water as it freezes and turns into a solid. With lava, it tends to do other types of patterns, and as it cools, it contracts. Those crystal structures sort of form those big giant columns that we see up at Palisade Falls. And those kind of columns are all over the world too. It's not just here in Montana. You can find that kind of stuff anywhere that there has been volcanic activity in the past. So that's basalt. Ooh, and this one's always really cool. Kids get excited about this one. Obsidian. If any of you play Minecraft, you of course know all about obsidian and how tough it is to chisel away with your Minecraft hammer. So, igneous rocks can look all kinds of different ways. I just wanted to talk about that with y'all. And then we've got metamorphic. And metamorphic rocks are very different from igneous rocks, but they still have the heat aspect about them. So if you were to take your hands, push them really hard together, and now move them really fast and hard, you start to create heat between your hands. Heat and pressure. That is what makes a metamorphic rock what it is. You can kind of hear the transformation that would go on with these rocks because of the name. If you think about like metamorphic animals that go through metamorphosis, so these are insects, these are frogs, things that change completely from their infant stage to their adult stage, metamorphic rocks do something similar. They transform an incredible amount. The heat and pressure of the earth, them being underground, actually can force them to bend in ways. And we see this sometimes in cliffs. If you've driven through the Gallatin, is it the Gallatin Canyon? Yeah, if you've driven through the Gallatin Canyon, where the Gallatin River flows through, sometimes you can see in those cliff faces along the way huge sections that have rock layers that are actually bent in half or bent in on themselves. That's due to metamorphic actions in the earth. Those are metamorphic rocks that have become that way. So this here is a metamorphic rock, super dense, super heavy. It's been not necessarily folded in those big dramatic ways that some of those rocks we see out in nature have. Nevertheless, it's a pretty cool example. And then, oh, before I even continue on, I'll show you all some little examples of various metamorphic rocks. Take a look at them all. And these ones start to get a little tricky for me. Like I said, I'm not a geologist, but they do have lots and lots of various components to them. Ooh, this one here, I believe is, I'll double check, number 22, I believe it's shale. Let's take a peek. Is it shale? No, it's coal. That's cool. So this one's coal. Coal is a type of metamorphic rock that has gone through extreme pressure and heat in order to form lots and lots of thousands of little layers that just melt together, essentially. It forms what is coal here. So those are all kinds of little examples of some metamorphic rocks. Let's go now to our sedimentary rock over here. And the sedimentary rock I really like this sedimentary rock. I actually got this one. I carried it down a mountain because it was so impressive. Sedimentary rocks have tons of layers in them, and they are essentially made up of hundreds of thousands of billions of tiny particles that have accumulated over time and have cemented together. That's the really important part. Sediment is anything that sort of becomes a much smaller particle than what it started as. As they accumulate, various minerals start to get introduced into the mix, and those things over time, as they are pressurized by water, because often sediments come from areas where water washes them away. Pressure of the water in oceans, pressure of the water in lakes will compress these things and cause it eventually to form a rock, just like so. So this is a really cool example of a sedimentary rock. It's my biggest rock I got. And I have some more examples, little examples of sediment. Let's see. So here's all my little examples. Again, they all look very different from each other. This one in particular is a really good example. You can see all the little pebbles in there, and those have all cemented together to form a sedimentary rock. Again, if you go to Palisade Falls has a really good layer underneath that basalt layer of sedimentary rock. And it's not necessarily small things like this. There are some huge boulders in there. Nevertheless, those giant pieces of sediment have cemented together, which is what is key. Everything accumulates, it becomes rock hard, it forms into a sedimentary rock. I want to show you all a different example of a sedimentary rock. I think this one's shale. Let me double check. Oh no, I'm sorry, limestone. This one's limestone. And it doesn't look anything like the last one I showed y'all. This one is made up of such tiny particles we can't really see it, and it all just looks like the same mass. However, limestone is prevalent in so many parts of the world. It's a really common rock to find, and it looks very different than our other sedimentary rocks there. Key to sedimentary rocks, though, is layers. Lots and lots of layers that accumulate over time and, again, cement together. So now we've gone over the rocks. Now that I've got the three major rock sections laid out for you, let's talk now about the rock cycle itself. I'm going to show y'all a little something, and we're basically going to replicate it in person. So here is the rock cycle. And notice the rock cycle isn't just a cycle that goes in one continuous circle over and over again. It's not like a clock. It has all sorts of directions that rocks can become other rocks, and it goes through all sorts of processes in order to get there. I'm going to start with sedimentary rock, and even before sedimentary rock, I'm going to start with sediment here. So let's talk about sediments. Sediments, once again, are those small particles that accumulate over time. They're often washed away by water, which is where we tend to find sediments at. And over millions and millions of years, those sediments will come together, they'll crush together. And I often like to do a little activity with my students. I'll say, go and find the smallest rock you possibly can. And they'll often bring back really small rocks, but eventually I try to get them to think about sand. Sand is pretty much just a bunch of tiny, tiny, tiny rocks. And they can get even smaller and finer than that too. These ones are quite large grain sands, but it gets the idea across. So we have sediments. Various rocks can become sediments through a process called weathering. I'm going to leave a little pile of sediment here so we can see it. Weathering is the act of rocks being torn apart, washed away, made smaller, and this can be physical, as if rocks banging together, or you could do this to yourself if you've ever taken a geode and crushed it with a hammer. That's physical weathering. You can also get physical weathering with chemicals. So sometimes rain has a different chemical makeup than what the rock has, and this might affect how the rock is worn down. Sometimes if rain has a pH, that's how acidic or not acidic it is. If it's a little bit more acidic than what the rock is, that rock might be washed away over time. You can see this if you've ever done baking soda and vinegar together. That's a really big explosion. Imagine that as a fast forward reaction that happens between rocks and water all the time. It's obviously not that fast, but it does give the idea of what's going on there. So I'm going to use some arrows, and I'm going to kind of recreate this rock cycle here. I'm going to use green for weathering. You can see weathering occurs from all the rocks there. Sedimentary rocks, metamorphic, igneous rocks can all be weathered, turned into sediment. So let's just start simply with that. Like I said, I'll use some green. Meow. Meow. Let me see how that looks on there. Perfect. So weathering occurs, turns those rocks into sediments, but like we said, those sediments have to now be cemented together. And in my rock cycle, something occurs called compaction. There it is, compaction. Compaction is the result of pressure. This might be the pressure of the water that these sediments have accumulated in the ocean. This might be compaction from the earth itself over time. But the compaction causes, oh, there's a plane flying overhead. I hope it's not too loud on your guys' end. The compaction eventually causes it to turn into a sedimentary rock. So it was purple on that sheet. I'm gonna use a little purple chalk and show that here. I mentioned last time how this can be something that y'all can do at home. I chose to do it with chalk, but I realized I could also do it with paper if I wanted. I wanted to be outdoors though today. I thought it'd be a little bit more exciting if I took it out to the outdoors and we used chalk to show this rock cycle. So we've got the weathering of various rocks in green turning into sediment. Sediment compacts and turns into a sedimentary rock. Sorry, my arrow's a little hidden there, isn't it? There we go. Turns into a sedimentary rock. Let's now move on to heat and pressure. Now, sedimentary rocks tend to be on the surface of the earth. They tend to be what's the word? What am I trying to say? They tend to be on the surface, but as soon as they start getting buried deep into the earth, as soon as any kind of deep earth pressure starts to occur, we start getting into more metamorphic rocks. So heat and pressure send these sedimentary rocks or these igneous rocks into the deep of the earth and start to transform the rocks themselves. In this little rock cycle thing, I've got heat and pressure in red, so I'm gonna take a red chalk and show that these things can melt into metamorphic rocks. Oh man, it's gonna get complicated here. Let's see, we'll do this one. Oh, it's gonna be pink instead of red. Sedimentary melts and has pressure, heats up and has pressure, turns into metamorphic. And same thing, igneous heats up, turns into, or has lots of pressure, turns into metamorphic rock. I've had students ask me, at what point does this happen? And that's a hard answer because the earth has various depths at which this could occur all over the world. Volcanoes themselves are kind of vents to the center of the earth. It's hard to say where metamorphosis might necessarily happen. There might also be varying pressures underneath tectonic plates because of the way the crusts and the plates move across the world. So hard to say. I've had students ask that in the past, and I really wish I had a better answer. Again, if there's a geologist watching, would love to hear from any geologist folks to find out what their take is on things. I'm not a geologist, but I know just enough about this stuff to kind of go over the basics. Ooh, I found a better red, everybody. Let's make this much darker. Oh yeah. Well, it's more like a hot pink. Nevertheless, it's a good pink. There we go. So, igneous can melt and it can have heat and pressure. It turns into metamorphic. Same thing with sedimentary. Follow that red line, goes to metamorphic. Now, we've got just a few more things. When the heat and pressure builds up so much that it literally starts to melt rock into liquid, that's where we get magma. Magma is always the fun part. Kids get really excited about the magma. So in this case, I haven't placed an area where there's magma on my rock cycle yet, so I'm going to do that. I'm also going to take the orange for the melting, and again, this is these rocks turning directly into a liquid. Magma is a liquid. It's liquid rock, which is pretty neat. It's pretty crazy that we live on a planet where that is something that can occur, that's something that the earth is so powerful it can create that. Let's see. I think what I'll do is I'll write magma and then I'll draw a little orange arrows to it. Mag. Ooh. It's so difficult writing in chalk. It's a hard thing. I don't know how kids do it. They're so good at it. All right. So magma And again, we don't have sedimentary rocks turning directly into magma because they first have to start to go into the crust of the earth. That's where they turn into metamorphic rocks. Once they're metamorphic, they can then become magma, and igneous, of course, can recycle itself and turn back into magma. But if you recall, igneous rocks can be both magma rocks that have solidified or lava rocks that have solidified. So this means that we can find igneous rocks on the surface of the earth, like this piece of scoria is, or we can find igneous rocks underneath the crust, which is where we get things like granite from. All right, I think I just have one more section of my rock cycle to go over. Oh, yep, this is my favorite part. Magma, after it cools, turns into igneous rocks, and that's exactly what I was just talking about. Actually, I got a little ahead of myself. I actually had a really nice blue chalk I wanted to use for that. It was super duper bright. So I'm gonna use blue to show the cooling of magma, and magma cools into igneous rocks, just like so. There we go. So friends, I think that's the rock cycle. I think that's everything I covered. Like I said, it's not a perfect circle. It doesn't necessarily travel in one direction. Things can occur over time to cause all kinds of rocks to go in any direction, to even repeat. For example, we could have sedimentary rocks forever just turning into sediments, compacting again, sediment and compacting again. Or we could have sediments turning into metamorphic rocks, weathering into sediments, going back into sedimentary. That cycle could go on for a while. Or we could have rocks that even go through the whole process too. And this isn't necessarily linear, and this isn't necessarily stopping at any point. This is occurring even today. It takes a long time for rocks to go through this process, but it is forever an active cycle that we are kind of on a plane of existence where we don't get to see it occurring right before our eyes. Maybe that's not true for volcanic eruptions, but for these other ones, they take a long time to occur. And it's always a neat thing that it's still happening even to this day. So folks, that's the rock cycle for you. I think I'll peel out from here. Thanks for joining us for another episode with Montana Outdoor Science School. We have live streams every week. Oh, I remember the last thing I wanted to talk about. In a build up to next week's live stream, let's go back to our sedimentary rock. I wanted to mention how sedimentary rock is my favorite rock because sedimentary rocks are where fossils occur. So on this sedimentary rock here, do y'all see that little circular thing? That is ancient sea life. That is the shell left over. Ooh, here's a really good example of a fossil there. Sedimentary rocks are the only rocks that fossils will occur in, and you can see why, because as soon as they start to have heat and pressure applied, they start turning into other things, or if they're weathered, they just become little itty-bitty bits of sediment, which actually, I suppose you could think of sandy beaches as just lots and lots of particles of ocean critters. A lot of sand on beaches ends up just being seashells that have come from those guys. There's, I think, a really good example. Ooh, this is a good example. There's a little fossil there. There's a little fossil there. So we'll talk about fossils come Wednesday, but I wanted to give you all a taste of that and kind of build up to it. Again, thanks for joining us with Montana Outdoor Science School. We will see y'all next time.